Hello, this is Mr. Stansbury. I'm going to take you through the notes on problem solving with trigonometry. At the end of this, you should be able to say, I can use trig ratios to solve real world type problems. Okay, so first thing, angles of elevation and angles of depression. Okay, so let's say here you are standing at the top of a building. As you look out to straight out, this is like a horizontal line straight out from where you're at. The angle of elevation would be what you look up to. So that's angle of elevation. And then from that horizontal line down to something you would look down to on the ground would be the angle of depression. Okay. Also, if you're here on the ground, you got this nice, it's always from the horizontal line. You're looking back up to this person. This would be considered the angle of elevation. Okay. All right. Let's take a look at an example. Example 8, Dave the duck casts a shadow of 28 feet. The angle of depression the shadow makes is 24 degrees. How tall is Dave? So let's draw ourselves a little picture here. Here we go. So we got to try to figure out how tall Dave is here. So we know that this is 24. This is horizontal. This is also horizontal. So back from your geometry days, we have two parallel lines, alternate interior angles. This here is also going to be 24 degrees. Okay, so this angle of depression is actually going to be the same as this angle of elevation looking back up to the top of it. Okay, so if we're looking for this side right here, this length, we have the angle. This is the opposite. This is the adjacent. So opposite and adjacent is tangent. Tangent of the angle, 24 degrees, is going to be opposite, which in this case is what we're looking for, over adjacent, which is 28. Multiply both sides by 28 to get the 28 out of the denominator, and we'll calculate that, and away we go. Okay, so we get 28 tangent of 24, and that gives us that Dave the duck is 12.5 feet tall. Okay. All right, let's take a look at another example here. We have find the pitch of the roof, which is the angle that the roof makes with the horizontal of this bouncy house here. So what might be a good idea is to draw the pitch of this roof. So we have this right here, this length here all the way across is 8 feet. And then this is 9 feet to the bottom, and then another 10 feet up. Sorry, 12 feet here. So the difference between 12 and 9 is 3. So this is going to be 3 feet here. Okay. So the angle that the roof makes with the horizontal, that's going to be this, which will be the same thing as that over there. So this cuts this side here exactly in half. So this 8 feet now makes that this is 4 feet, and this is over here is also 4 feet. So here's our angle. These are the two sides that we know. So this is the opposite side, and this is the adjacent side, right? So opposite and adjacent is tangent. So we will use tangent theta equals opposite, which is 3, over the adjacent, which is 4. So we will get our calculator out to help us. We're looking for an angle, so it's going to be second tangent of 3 divided by 4. And that gives us 36.86, so 36.7 degrees. Okay, so the pitch of that roof is 36.7 degrees, right? Yep. No, 36.9 degrees. There we go. Okay. All right. Let's look at another example. Let's see. There we go. Jade and Navy are sailing when they notice Mega Mouse peering over the edge of a cliff. If their boat is 200 feet from the base of the cliff, the angle of elevation to the top of the cliff is 31 degrees, and the angle of elevation to the top of Mega Mouse is 64 degrees. How tall is Mega Mouse? So what we want to do is we want to draw ourselves a triangle in here so that we can figure all this out. So I have done that for us. So here's the ship to the base of the cliff here. That's a nice horizontal line. The angle of elevation to the base of the cliff is 31. The angle of elevation to the top of Mega Mouse is 64, and we're trying to figure out how tall Mega Mouse is, right? Okay, and it's important to note that this ship is 200 feet away from that cliff. So here's what we want to do. We want to find the big triangle to the top of Mega Mouse, right? And then subtract the smaller triangle to the base of the cliff, because this will be the base of the cliff. This is the base of the cliff and Mega Mouse. So if we subtract those two, we get the height of Mega Mouse. Okay, so let's see here. This cliff here, sorry, to the top, we know that this is 200 and this is 64. So this is 64 degrees and that's 200. And then for this other one, this is 31 degrees and 200. And we're on both of these cases, we're looking for x here. So from this angle, that's opposite, that's opposite, and this is adjacent. So that's going to be tangent. Tangent 64 is opposite, which is x, over adjacent, which is 200. So multiply both sides by 200, right? And we get x is going to equal whatever 200 tangent 64 is going to be. 200 tangent 64 gives us 410. So 410 from the base of the ship to top of Mega Mouse. And then we also got to figure out this one here. So this is also opposite and this is also adjacent. So that's just going to be tangent of 31 instead of 64 equals opposite, which is x over 200. So multiply both sides by 200. And that will tell us what this x here is. Oops. Okay, so 200 tangent 31. Tangent of 31 gives us that this is about 120 feet to the top, from the bottom of the cliff to the top of the cliff. Okay, so all we want to do now is take 410 minus 120, and that is going to give us, what, 290 feet. So Mega Mouse is 290 feet tall. That's a pretty big mouse. Okay. We have one last example, but before we do that, let's do a quick little comedy break, shall we?
I don't know why players argue with umpires. Every game you'll see a player argue with an umpire, and I've never seen an umpire change his mind ever. So why would you waste your time? Has that ever worked? You ever see a guy sliding into home? You're out! You're crazy, man. He missed the tag. I had my hand. Okay, safe. I don't like conflict. I tend to shy away from that. Go ahead, give him a run. No, it's okay. I didn't know about the yelling. It's okay, give it to him.
All right. Last example here. Okay. So find the measure of DFG, and this is a little IB notation here for angle. So we're trying to find the measure of DFG. So what that is showing us, here's our angle from D to F to G. Okay. So let's just redraw this here so that we can actually see this triangle in 2 dimensions here. So there it is, D to F to G. We know that this FG section right here is 8, because this is doesn't tell us, but we have to assume that it's a rectangular prism here. So this is 8 meters here, okay? We don't know what this side is here, but we could figure that out. But we don't really want to know what that is. We want to know what this is here, right? But you know what? Actually, it doesn't matter. We can find this side or this side. So you know what? Let's find this side right here. Okay, so we want to figure out what this side is right here. So guess what? This is a right angle right here as well. So we can just do, this is 7. This side is here is 10. So we can just do 7 squared plus 10 squared to get us this C squared right here. So that's 49 plus 100 is c squared, so that's 149 is c squared. So we're going to square root both sides and figure out what c is, right? So we take the, oops, we don't even have to do, oh yeah, we do second square root, oops, not what I wanted. Square root of, there we go, 149. And it gives us square root of 149. Remember, if you hit the little double arrow button, it'll give you a decimal, so 12.2. 12.2. So this dotted length right here is 12.2. So this right here is 12.2 meters as well. So now we're looking for this angle right here, right? So from this angle, that is the opposite, and this is the adjacent. So we want to do tangent. Theta is opposite, which is 12.2, over the adjacent, which is 8. Okay, so bring up our calculator. Whenever we're looking for an angle, we always do second. So second tangent of 12.2 divided by 8 gives us that angle is 56.7 degrees. Okay? Okay, so that's that angle right there. Okay, that's all there is here for the problem solving with trigonometry. If you have any further questions, please feel free to ask in class. Thanks.